Okay, this is one example I wanted to talk about in class to motivate conservation of energy, but we were a bit short on time. So let's take this situation. So based on your knowledge of kinematics, how would you approach this problem? And the problem is that we have three cannons that are arranged as shown below so that they shoot identical balls simultaneously with the same initial speed v from the same height, and we want to solve for the final speed of the ball, assuming that it is fired a distance h above the ground. So we know this height is h, and all of these cannons are oriented in different directions. So the first one shoots a ball with a initial speed v in this direction and follows some trajectory like this. The next one shoots the cannonball straight down. By the way, we can assume that this velocity here makes an angle of 45 degrees with the horizontal. And then finally the last cannon is shot horizontally out and follows some trajectory like this. So knowing our knowledge from kinematics, for each case we can do case 1, case 2, case 3. By the way, make sure you pause the video and think through how you would approach this using kinematics, because this is a perfectly fine example for your final exam or another exam where you're having to use kinematics to solve this. So what you might do, let's say for case 1 or case A, case B, and case C. You might split up your given information and what you want to find in the x and y direction. So you'll say v initial x is something, v initial y is whatever it is. It's going to be v sine of 45 degrees, and v initial x is, if we use a coordinate system that where positive x is to the right, positive y is upward, v initial would be negative v cosine of 45 degrees. And then we can write down the fact that acceleration is 0 in the x, acceleration is minus g in the y. We want to find v final x, we'd like to find v final y. We know delta y is equal to h. Or actually, delta y is negative h, because it's traveling downward eventually. Basically from here to when it lands down here is what you're interested in. So you could start with the y direction, calculate your v final, calculate the time it takes to get there, and then plug in that time into the x direction to find v final x. Once you have v final x and y, you can find the magnitude of it. Then you could do a similar thing, but in the case B, all our motion is solely in the y direction, so it'll be much easier. And then for case C, our initial velocity is in the x direction, but the motion is both in x and y, so you could do something similar to case A to calculate v final. Now, there's actually a slightly easier and faster way of doing this problem, and that is using conservation of energy. So the other way is realizing that the only force, so as we consider the cannonball, as it travels through its trajectory, the only force acting on it is the force of gravity. And as you might remember from our discussion in class, force of gravity is a conservative force. There is no dissipation of energy happening. So we can look at the initial energy as the ball is launched, and then the final energy right before the ball hits the ground, and we can set the two equal to each other because throughout the trajectory of this ball, total energy of the ball is staying constant. So when it starts here, it has both kinetic energy, which is equal to some 1/2 mv squared, and it has potential energy, which is equal to mgh. And then when the ball gets to this final point, it has now kinetic energy final, which is 1/2 mv final squared, and it no longer has potential energy because we're setting our y equals 0 at the ground here. So since it's basically just about to hit the ground, our y is 0. And then basically equating the sum of the initial kinetic and potential energy to the final sum of kinetic and potential energy, you can solve for the final velocity. And what you'll notice is the initial kinetic and potential energy for each of these balls is exactly the same. Even though they're being shot in different directions, that doesn't matter. What kinetic energy cares about is what is the velocity and what's the mass. And then what potential energy cares about is what's the height from which you're launching. And they're all being launched from the same height, and they're all being launched with the same speed, and they have the same mass. So for all three cases, the initial energy is the same, and what you'll come to find out is the final energy also has to be the same, because all three of them, right before they hit the ground, just have kinetic energy. So that is another strategy to solve a problem like this.